Well, without further ado, my name is Paul Gapes. I'm the General Manager of Pacific Data Systems, and today we're having a Technology Open Day. That's been a joint operation with AST, Hughes, Inmarsat, and also Skywave. A bit of housekeeping for those that haven't been here before. Toilets just to the left-hand side there. So those of you who do smoke, we have a smoking point around past the barbecue. I think there still might be some sausages and rolls left. For those who are hungry after the presentation, have yourself to the sausage and a cold drink. A little bit about Pacific Data Systems. George Porter, Managing Director in the far back corner there, started the business almost 30 years ago. And here we are today, 22 strong. Recently put an extension on to house an automated pick and place machine for our own printed circuit board design relation for some controllers and sensors that we're building at the moment for control fruit ripening. So there's some exciting things happening. So my involvement with Pacific Data Systems has been with Pacific Data Systems for 7 years. Started out in technical sales, went into a sales management role, and recently appointed General Manager in July of last year. Before that, I was a member of the Australian Defence Force. I have 2 service badge. I was with the Air Force for 3 years as ground defence, and moved across to the submarine service as an electronic warfare analyst. And I guess that's where a lot of my interest in systems and electronic systems came to the fore. And fortunately now I'm working with a very progressive company like Pacific Data Systems across a broad range of technologies. So the main aim today is to give you introductions to people like Dwayne McTavish from Hughes, Cliff White from Inmarsat, Neil Jonathan from AST, with Keith Richardson over in the corner over here, Vince Brennan floating around somewhere. We have Travis Boland in the suit jacket from Skywave. So after this presentation, we encourage you all to hang around and look at some of the systems that are on display in the courtyard there and talk about some of the problems you're currently having with your monitoring, remote monitoring requirements, and see where we can be of service to solve those problems. Neil, did you want to add anything onto that?
No, I think
as an introduction.
Like we said, is after the presentation, if you could just hang around and grab one of the guys that you want to discuss anything with, whether it's myself or the Inmarsat, Skywave, Keith, any one of us that you may want to talk to from Pacific Data about a specific requirement or solution. Don't feel that because the presentation's over that's finished and you get off you go. We want to hear from you what systems you're working on or any requirements you may have, and that's what it's about today is let's network, let's understand what it is. Dwayne's obviously got a lot of good insight from processes and things they do in the US, for example, and Cliff obviously from a lot around the world as well. So there may be questions you want to bounce off about how they do things that you're trying to achieve elsewhere in the world as well. So get the information you want out of today for yourselves. I think that's about it.
All right, thanks, Neil. So today's presentation is just designing a basic remote monitoring system using satellite telemetry. It's a very broad brush. A lot of you have a lot more experience with remote data acquisition. I know the hydrographic support section are heavily involved with remote data acquisition, so building your own controllers and that sort of thing. So, it's hard to put together a presentation when you have a broad experience base and different depths of knowledge and things. So, like, I'm a big believer in before you start any task, all comes down to the preparation before that task is comes to fruition, and you see the results of what you're doing. So not only do I use this in the work environment, I also use this slogan on the home front as well, and when managing sporting teams and so forth. So I guess you can probably guess what the question mark is. So what we're going to talk about is what do you need to sort of things you need to think about when the sensors you're going to use, how you're going to go about it, where that remote monitoring location is, depending on types of satellite or remote telemetry you're going to employ. The why, well, usually the why is because you've been told you have to go and do something, and look at how we go about that, putting that system together. So if you don't do these things properly, it's a fairly powerful image that. If you don't do the monitoring and control properly, you can come unstuck, or in this case, stuck. It can create a few headaches. So we have a requirement here. There's a timeline to provide that solution, and the first thing that we look at is, okay, you've been asked to go and do something. So it comes down to sensor selection, which is the first port of call. What parameters do you need to measure? What technologies are employed with that particular sensor? The accuracies of those sensors, the resolution the sensors providing. The other thing is that from a power conservation perspective, if it is a remote application and you have solar panels and backup batteries and so on and so forth, how often do you need to power up that sensor? And for that power to be, for that sensor to be stabilised, so you can take an accurate reading from it. Some of the sensors you deal with, Scott, water level monitoring, pH, GC, any weird sensors out here that we may not have heard of that anyone's utilising? So the next is the data logging, RTU, PLC. There's a wide range of hardware devices out there. From a general purpose data logging platform like a data taker, and dare I say it, Campbell Scientific data loggers, through to RTUs. This is a T-Box from a company called CNC Semaphore of Belgium. This one's a high-speed data acquisition system from a company called Gantner. We have a design and manufacturing facility in Schruns, Austria, and Skywave also has these types of devices here, have the ability to store small amounts of data and then forward. So how do you go about choosing one of these? Well, what sort of analog digital interfaces, inputs and outputs that they have, what's the sampling speed of the device? This device here is, the data taker data logger is typically good for sampling speeds of 1 Hertz. And then you've got this type of device here that's 100 kilohertz sampling rate, which is used for a lot of pre, during and post event capture analysis. Airbus use these on measuring the strain on their wingspans through that build process. And some of these devices have a web server that you can access for configuration and also monitoring. There are other devices out there from ABB, GE, Red Lion, a whole range of data logging platforms. Some of these also have communication modules already built in, and which from an integration perspective can make it a lot easier instead of bolting on a module, a third-party module. Typically they are only 3G type radio communications that are actually integrated with that unit. I haven't seen any to date that have a satellite telemetry module fully integrated into them. Has anyone seen any to date? So this is why we have the providers of hardware like Skywave and Hughes to provide that capability for integrating with these types of devices. So a big headache with any remote monitoring application is the power. Where do we get the power from? Well, typically, there's two ways of going about it. If mains power isn't available, then you have to resort to solar. When there's solar panels out in the field, and they become an attractive item for theft. So then you have to worry about security of the installation. One of the ways to address and reduce the footprint of the solar panels and the backup battery is to try and manage the sampling rate inside the actual PLC, data logger, RTU, whatever it may be. If you don't need to monitor 100,000 times a second, I know it's fairly obvious, just reduce the sampling rate. And also that'll probably reduce a few of the headaches post-capture when you have to provide, conduct the analysis prior to presentation. This is an installation here at Zippy Downs Drive, at Zippy Downs, outside the University of the Sunshine Coast. And it's a system we put together that measures pavement characteristics when traffic is flying past that particular point where the sensors are installed. The reason why I put this slide up here is that this is a high traffic area, and being out in front of the university, they want to maintain a certain level of aesthetics. So instead of having a large solar panel mounted on this pole, we decided to reduce the solar panels. Some may say that's better looking than an 80-watt solar panel versus 240s. So they may have a different opinion. So this system basically measures the horizontal tensile strain in the pavement, the vertical tensile strain in the pavement, the soil pore pressure, and it's to provide data for predictive analysis. And what they would like to do is each new section of road that is built every 10 kilometres put one of these systems in place to provide the information back so they can make operational and future planning decisions. It also has an IP camera on there, so when the actual alarm threshold of the horizontal tensile strain is triggered, it then takes an image of the vehicle in question, overlays the data on an image, and pushes that image back to an FTP server. There's also a weather station sensor atop there. Some of you may be familiar with it. It's a Vaisala all-in-one weather sensor, all-in-one WXT520. Measures all the standard weather parameters and also has a rain and a hail sensor. There have been studies done in Malaysia about this rain sensor against a conventional tipping bucket rain gauge. And the executive summary indicated that the main difference was mechanical reliability. And from a performance level, you can see too much shifting of the accuracy of the data. Just frogs and leaves and the tipping bucket rain gauge that create the problems. So you're getting back to the solar, that's one of the considerations, is particularly in high traffic areas, aesthetics, but for any other remote sites in less populated areas, I think security may be a concern. So the telemetry side of things, that's what we're pretty much here to talk about today. Hughes and Skywave are two hardware manufacturers to support satellite telemetry. And then you have a couple of satellite constellations that just the medium where the data is sent from those devices to wherever you want in the world, basically. Some of us are familiar with the 3G, 4G, long-term evolution modems. I don't know if anyone's seen Watch TV recently, and they had Vodafone now have 1 million 4G connected customers. So it's certainly a growing area. Radio, there's a wide range of radio topologies that you can deploy depending on your application, whether it be point-to-point, point-to-multipoint, so on and so forth. There is another method of communication that I read about recently. It's called Wi-Fi. It's light fidelity. It's where they're using LEDs to switching on and off of the LEDs at high rates in order to transmit that data. You may want to have a Google of it. I don't know if you know anything about it, Scott. Has anyone here heard of it?
Yeah, a while ago.
Yeah, a while ago. So I think the University of Scotland's doing some work on it. So I think that's the next big boom with regards to personal area network communications. Stay tuned. This is one of the satellite constellations that's available for yourselves or your clients to as the transport medium for that data coming back. Cliff, did you want to make mention of some of the developments in Inmarsat going forward?
Yes, thanks Paul. So the Inmarsat network, it's a global satellite constellation, but it's based on the 3G cellular network. So basically we put a 3G cellular network in the sky. We actually have cells in those big beams there. That's the way we control the network. But Inmarsat are starting to invest heavily in making our network support more of these remote monitoring applications. And we're working closely with like Hughes and actually we'd like to hear from yourselves on what you need in our terminals and our network to support your services better. But we're bringing out a whole new range of smaller, faster, lower power terminals that have all remote management features in them to support this industry. So Inmarsat's really, the Hughes 9502 is probably the first, one of the first main end-to-end terminals we work with, and Skywave on the LDR. So we have a broad range from high bandwidth, 500 kilobits per second down to storm forward. The message size is 10 bytes at a time for some of the, with Modbus built into some of the Modbus engines and RTUs built into units. So we're about, our satellite constellation is being expanded as well. We've just put up a new satellite in July last year, and we'll be maintaining, this satellite constellation operates in the L band. It was designed for maritime communications. So it's supposed to handle the harsh weather, the harsh environments exposed to the maritime environment, and it's very well suited for especially outback Australia, It's just pretty tough what it operates. So it's different to normal satellite, easy to use, low cost. So it's really, we're sort of changing the face to try and meet what you guys need. So that's.
So from a low cost perspective, there is a general understanding that when you mentioned the word satellites, but like when you mentioned wedding to organisations, the price, you automatically think the price is sort of out of reach. We recently supplied a system to a company in Mackay who build these very large dewatering pumps for open cut mines, and they wanted to be able to tap into their engine management unit and read their CAN messages from this engine management unit. And at the moment, based on how they want to access that data, it's costing them about $100 per month. And if a technician was actually to go out on site to have a look at their system, it would certainly cost them more than $100 to do that. So they are certainly within reach these days with respect to pricing. So the next one here is the Iridium satellite network, and this is more for short burst data messages, hundreds of bytes versus kilobyte type application. You can send multiple messages, but there's short amount of data. So the network obtained its name because the intention was to have 7 planar orbits circling the globe with 11 satellites on each orbit. So a total of 77, which just happens to coincide with the elemental number on the periodic table. Whereas in fact there are only 6 planar orbits up there with 11 satellites in each orbit, spaced 30 degrees apart. So they really should have changed their constellation name. The guys are crazy for me as putting camera set there. But yeah, so from a differentiation with regards to constellations, small amounts of data, short burst data, Iridium, anything into the kilobyte, megabyte type applications in Inmarsat is the way to go. Software. Obviously, the devices need to be configured, and then there needs to be a graphical user interface of some type for the end user to look at and interpret that data coming back. These are some of the software interfaces we've utilised in-house for some of the applications. This is the screen or tropical fruit ripening controller that we've developed in-house from the ground up. It's taken about 2.5 to 3 years. Now we're supplying these types of devices into Singapore, and it's to control the ripening of tropical fruits like avocados, mangoes, durians, avocados, etc. So we measure things like carbon dioxide, ethylene, relative humidity, temperature, oxygen in some cases. And if we need to accelerate the fruit ripening process, we inject a BOC product, ripe gas, which has a certain percentage of ethylene in there. And it's my understanding that 2 parts per million of ethylene start that ripening process. This other unit here, this interface here, this is for the recent project for the Department of Transport and Main Roads. So they are required to lift a bridge section in a controlled manner using Enerpac hydraulic rams, and they need to measure the displacement as being raised, so there isn't any twisting and buckling in that bridge section. And we use these magneto-restrictive linear displacement transducers, which is a fancy name for a ruler, to measure the lift, the displacement that's being lifted, and that's the interface that we wrote, utilising the third-party software from a company out of Italy called Cialco Sistemi. Some of you may be familiar with this interface. It's a web interface that's resident on board the data taker general purpose logger, and you can basically configure the interface primarily through an Ethernet cable and via a web browser. The other thing we did do is more of a marketing exercise, was develop an iOS Android application specific for the data taker. And an example of utilising this would be workplace health and safety officer is on a mine site and he gets a high dust alarm, so then he calls up the water truck operator and says, right, come on site, put water here, there and everywhere to suppress the dust. So a very easy way of seeing that data. There are a number of different graphical user interfaces that we've put together over the years. So after the unit's been built, the software's been written, configured, what have you, and we go through a factory acceptance test, a system acceptance test with the client, with your client, wherever it may be. You may want to do this with your clients. And here's a picture of Helen Chen, our electronic production officer, and some of you may have seen it through the tour recently. It's an electronic pick and place machine. So all their own designed printed circuit boards, they come back in-house, and then we automatically, we put them in this machine and automatically populates those components. We can place up to 6,500 components per hour onto these. David Huckman, our technical officer, this is a system that we're building for Maritime Safety Queensland, water monitoring application. One of the recent boxes that just went out the door on Friday is a sodium cyanide control and monitoring control system. So they basically want to reduce sodium cyanide on the site. The main driver for that is a reduction in costs for production, and also improved handling of the material. It's quite a complex box. And then there's the install process, and then there's the commissioning after that's been done. This one was this station here is a solar tracking station. It's Collinsville Power Station, 67 k west of Bowen, and basically it is collecting data to determine whether it's a suitable site to install a solar farm. It's under the federal government's National Solar Flagship Program for using it.
The solar farm, is it a solar panel or a solar thermal concentrated plant?
No, it was a solar panel. Yeah, I think the thermal concentrator is one in Western Australia. It's a fairly large project. So this is a fairly fancy bit of equipment manufactured by a company called Middleton Solar, Cardiscott Design. It's a pyroheliometer. It basically measures the centre, the radiation from the centre of the sun. And it tracks the sun as it's going across the horizon. So there's an onboard GPS. So when the cloud goes between the sun and the sensor, and it goes into a passive tracking mode. And then when the sun reappears, when it goes into an active tracking mode. and it should know from, based on the lat and long of this particular site, it knows where the sun is at any particular point. So yeah, you come up with the end solution, and hopefully the data that's being captured from the field is a reliable source of data that can be utilised for operational or future planning performance for whatever applications.